Hi, and welcome to Introduction to Engineering. In this class, you're going to be exposed to all the different engineering disciplines, and I hope you get to have fun along the way. So let's go ahead and get started. So in your learning management system or in your engineering notebook, go ahead and take a second to answer this question. What is engineering? What do engineers do? Also, try to list as many possible engineering disciplines as you can. So pause the video, take a second to answer these questions, and then start the video again. Okay, great. So one of the key things that we have to talk about anytime we talk about engineering is safety. Safety is hugely important. And in fact, there's an entire category of engineers called health and safety engineers that apply safety in engineering situations. They want to protect people and property from damage and make sure that everyone works safely. And if you had any doubt about the importance of safety, safety engineers make an average of $91,000 a year. So that tells you that companies think safety is very important, and you should also think that safety is very important. So be sure that throughout this entire class and all your projects that you work safely for the safety of yourself, your teammates, and your teacher. Okay, so what we're going to learn today is what it is to be an engineer. We're going to learn about the different engineering disciplines, particularly those offered at LSU, and understand how engineering success and failures impact the world around you. So just so that you know, the class is basically broken up into three parts. So the first part is going to be an introduction. We're going to talk about ethics, professionalism, work ethic, kind of your 21st century soft skills. Then you're going to have 1 week in each of the engineering disciplines. So that'll consist of a guest speaker whenever your teacher can get one, or a video of one, especially if you're doing this in an online format. Then you're going to do a hands-on project in a team, and you're going to write a lab report and keep an engineering notebook. After you finish the project, you're going to have to present your findings to the class and then take a quiz on the discipline. For those of you who are doing this in a full year, in between part 1 and part 2, you'll actually have additional projects. So we're going to go over how to write a good lab report and some additional supplementary fun projects. Okay, so guest speakers are going to be coming into your classroom. So one of the things we need to talk about is professionalism and guest speaker etiquette. So you want to actively listen. So that means that you're not sleeping, you're not putting your head down, you're not talking to your neighbor, you're actively listening to them, maybe like nodding along with them, but actively listening, not just having your head down. You want to show interest. So again, that goes kind of along with nodding or shaking your head, or you could even ooh and ah if they show you something really cool. This doesn't mean shoving people aside if there's some sort of demonstration and being the first one to see it. It definitely doesn't mean sleeping while they're presenting. So you want to make sure that you're showing interest. So it would not be appropriate to raise your hand and ask the guest speaker if you can go to the bathroom, or to interrupt them and ask your teacher to go to the bathroom. Just need to be respectful. Be free of distractions. So you shouldn't have your computer out. You shouldn't have your cell phones out. I know we really want to take notes sometimes on our computer, but computers are a huge distraction. So unless you have really good self-control, which I don't possess, you really don't need your computer out. Just jot some notes down on a piece of paper, old school style. Applaud where appropriate. So it's not appropriate to applaud after every single slide. You would want to applaud the end of the presentation. Or if they show you a really cool demonstration, you can applaud at the end of that. Even if their presentation was bad or they were hard to understand, you definitely want to still applaud. They took time out of their day to be in the classroom with you. So you want to make sure that you respect them and respect their time. Thanking your guest speaker, that's really important. Again, they've taken time out of your day, out of their day to come to your classroom, and so you definitely want to thank them either as a class. You could ask for their email address and send them an email thanking them. You could even write them a thank you card and have your teacher mail it. So you definitely want to make sure you thank your guest speakers. You're a reflection of yourself, your school, your teacher. So just overall, be respectful, be attentive. This is an important part of the class so that you guys can actually interact with real live engineers and ask all the questions that you want. So make sure that you are appropriate when you have a guest speaker in your classroom. All right, so now that we've kind of gotten the logistics out of the way, let's talk about STEM. So what is STEM? Science, technology, engineering, and mathematics. And how do they work together? Okay, so there's a little quote over here, the best way to have a good idea is to have lots of ideas. And so STEM helps us generate those ideas. Okay, so you definitely want to have a lot of good ideas, or to have a good idea, you have to have lots of ideas. And so STEM can help us do that. So scientists work with the natural world to discover new opportunities. So basically, they're going out in the world and they're discovering new things. Mathematicians use algorithms to solve complex problems. So they're figuring out how can we mathematically solve this concept. Technology is what allows math and science and engineering to be easier, because isn't it much easier to do complicated calculus using a calculator than it would be to do it by hand? Computers and the internet help us. And all three of those things come together so that engineers can use technology, math, and science to ultimately solve problems. So a scientist might find this new bacteria. Well, the engineer is going to take that bacteria and use it to solve a crisis, or a mathematician might discover an algorithm to increase efficiency, and the engineer is going to apply that algorithm to a plant and make that plant better. Okay, so what is engineering? We've kind of heard STEM, we've heard one definition, but let's hear from a few other people. So engineering problems are underdefined. There are many solutions, good, bad, and indifferent. The art is to arrive at a good solution. This is a creative activity involving imagination, intuition, and deliberate choice. So I really like this definition by Ove Arup. I'm sure I mispronounced that, but he is actually a very, very famous engineer who founded a multinational corporation that offers engineering, design, planning, and project management. So he's actually considered one of the foremost architectural structural engineers of his time, which he was alive from 1895 to 1988. Okay, but I like it because he says that it's an art, and engineering really is an art. There's not a single solution, where science, you kind of think there's one answer. It's either proven or disproven. In engineering, you can always make it better, it just might become cost prohibitive. Okay, so when the only tool you own is a hammer, every problem begins to resemble a nail. This is actually by Abraham Maslow, who was actually a psychologist, and he developed the Maslow hierarchy of needs, which is one of the ways that engineers solve problems. Okay, Neil Armstrong, science is about what is, engineering is about what can be. And last, Henry Petrosky, failure is central to engineering. Failure is central to engineering. Every single calculation that an engineer makes is a failure calculation. Successful engineering is all about understanding how things break or fail. And he was actually a failure analyst or a failure engineer. And he is still alive. He was born in 1942 and he is still alive. So these are all different definitions of what an engineer does, okay, or what engineering is. But my favorite definition actually comes from Wikipedia, surprisingly. Wikipedia doesn't always get things right, but here it is. Engineering is the discipline, the art, skill, and profession of acquiring and applying scientific, mathematical, economic, social, and practical knowledge in order to design and build structures, machines, devices, systems, materials, and processes that safely realize improvements to the lives of people. So really, engineering is multidisciplinary. The goal is to solve problems safely. ABET is a accrediting agency, so they are actually the board who approves schools to issue engineering degrees, and they define it as engineering sciences are based on mathematics and basic sciences, but carry knowledge further towards creative application needed to solve engineering problems. They bridge the gap between mathematics and science and engineering practice. So they define it a little bit differently. I don't like this definition. I don't feel like it's as thorough as the other one, but I think it's important because ABET is the one who recognizes when universities are offering high quality degree programs. And to become a professional engineer, your degree has to come from an ABET accredited university. We'll talk about that in just a second. Okay, So now that we know what engineers are, what do engineers do? So take a second to think about it. Maybe pause the video, talk with your neighbor. What do engineers do? Well, they do a lot of things. They research, build, analyze, design, create, invent, innovate, evaluate, collaborate, plan, all these different things, and then they implement. So these are all different things that engineers can do, but invent and innovate are really the key things here. So what's the difference between an invention and an innovation? Let's take a look. So invention, this is a wheel. It's the very first wheel that was ever discovered in 3150 BC, so 5,000 years ago, is a wheel. And here's an innovation. So it's an improvement on that wheel, and we're constantly innovating. So most things that we do are not necessarily inventions, but innovations. Okay, so they're improvements. Okay, so an engineering career is kind of the crossroads between teamwork, problem solving, communication, and computational thinking. And so we're going to spend these first couple of weeks really exploring these different aspects of engineering. And then we're going to take a deep dive into each of the different engineering careers. But no matter what discipline you study, these four things are really holding it all together. So I don't know how many engineering disciplines you had, but go back and look on your bell ringer and see if you came up with these. So the US government tracks 17 different engineering disciplines, and you'll notice health and safety was that one we mentioned at the beginning, and that is one type of engineering, but there are a lot of different types of engineering. So these are 17 different ones that are tracked by the government. There are a lot of minors and sub-concentrations and specialties and concentrations within these, but these are the big, broad umbrella. So what we're going to look at is what's offered at LSU in the College of Engineering. So you'll notice that there are 9 of the same ones that were on that list, but we've also added computer science and construction management. So these are not true engineering disciplines in the pure sense of the words, but they are housed under the College of Engineering at LSU, and they are vital to engineering. Also, in this class, we're going to be combining electrical and computer because they both deal with the hardware side of a system. So that will be into one discipline. So you'll have a total of 10 disciplines that we're going to be exploring. As I mentioned, there are a lot of different minors. So within these concentrations, you can get all these specializations: nuclear, robotics engineering, structural engineering. So sugar engineering, sugar is a big field here in Louisiana with all our cane fields. So you have concentrations, but we're going to focus on the 10 primary majors. I also want to mention that LSU has a neat fast track program, so you can actually get an industrial engineering degree and an MBA in 5 years, which would typically take you 6 years if you did a full program. It is difficult to do because you have to take additional courses each semester to finish early. There's also a biological engineering fast track. So if you want to be a doctor or go to med school or anything like that, you can get a BS in biological engineering and kind of jumpstart that process. All right, so biological engineering. This is where we're dealing with living organisms and systems. And they're doing research, so like prosthetics and medical devices would be something that biological engineers work. But the key here is they're working with living organisms, and they're solving problems related to living organisms. Civil engineering is really on infrastructure. So civil engineers build bridges, civil engineers design roads, they design sewage systems. All the things that are part of an infrastructure of a town are designed by civil engineers. Chemical engineers. So it's actually, chemical engineering can be a really broad field, but basically they're doing chemical reactions, usually on a large scale. So the difference really between chemical engineering and chemistry is that chemistry is done in a lab in a very small scale. So they're testing to see if this interacts with this and produces a usable product. Chemical engineers are actually taking what they see in a lab and they're upscaling it, they're making it larger, and they're trying to transform material into something else. Electrical and computer engineering. So they design systems that use electricity. So like I mentioned, this is hardware. So they're designing the circuits, they're figuring out how much voltage and current to make sure things don't blow up, things like that. Computer science, so it's using computers to solve problems. So it's talking to a computer in a language that it understands, and there are a whole bunch of different programming languages, and using that technology to solve problems. Construction management, this is the other one that's not your traditional engineering field, but they actually oversee entire construction projects. And so they are extremely important to the field of engineering because they have to work with engineers, they have to understand engineering drawings, they have to do materials scheduling, safety, and they have to communicate between all of those different parts of the construction process. Environmental engineering. So again, this is different than an environmental scientist because an environmental scientist does something in a lab, whereas an environmental engineer is actually going to work on solving a problem, and they're usually designing something to solve that problem. So waste disposal, recycling, pollution control, land, air, and water. They're dealing with those three components and figuring out how do we clean the land if it's already dirty? How do we create a device that would reduce pollution, things like that. Mechanical engineering, so this is probably one of the ones that you came up with. It's pretty widely known, and basically they're designing and manufacturing. So they're all about machines, mechanics, principles of motion, and this is a picture of tiger racing. We have a great mechanical engineering department at LSU that's focused on automotive. There's actually an automotive minor where you can go to Italy and study, and it's really cool. Industrial engineering, so that's actually what I am. So industrial engineers, the big catchphrase is that we're imaginary engineers, but that's because we don't really create new things, we improve processes. So if it takes you 3 hours to produce one output of product, we're working on ways to reduce that 3 hours down to 1 hour so that you can have a higher volume of output. So industrial engineers are all about efficiency, improving lean manufacturing, as well as quality control. Petroleum engineers. So petroleum engineering is different than chemical engineering, and it might be one that you didn't mention, but petroleum engineering has to do with finding and producing natural gas and oil. So they are going to go out in the field, they're going to dig around, find some oil, and extract it from the ground. Okay, so this is a short video that I'll post in the metadata that you should watch and answer these questions on. So we're not going to play it here because it's weird to have a video playing in a video, but the link is right at the bottom there. It'll also be posted in the metadata. So go ahead, and it's about 7 minutes long, and watch this video and answer these questions. So what kinds of things can engineers do? Really, it's unlimited. So you can climb the corporate ladder. So that's where you would be an engineer at a plant, and then you would be a manager of maybe an operation unit in the plant, and then you'd become a supervisor and work your way up the corporate ladder. You could be an independent entrepreneur. So that means you start your own business. So maybe this is something that you might do after you've worked in industry for a little while. So maybe you're tired of the corporate ladder and you decide to start your own consulting business. So you would go advise companies on different engineering processes that they should do. You can go into the military. So the military definitely needs engineers. You can go abroad. So if you wanted to go into different countries, you could work for a company and get sent over abroad. You could go to a school for a lot more than 4 years and pursue academia or become a professor. You could do research. So, I mentioned that a lot of chemists, you're working in a lab, and chemical engineers are working at a plant, but there are a lot of opportunities for research as an engineer. And you could do some sort of mix of any of these, right? And so you could start in one, end in another. Your whole career, you don't have to do one thing the whole time. I do want to mention that there are a whole bunch of other careers out there that aren't engineering disciplines, but they are certainly careers that you could pursue and that this class will prepare you for. So we're not going to be doing any welding. We're not going to be machining something on a CNC machine, but we're going to be teaching you some really valuable skills that are transferable no matter what discipline you pursue, and it will definitely prepare you for some of these career tech fields that you might be interested in. Because engineering is not for everybody. It's hard. There's math, there's science, there's all this stuff. Because a lot of times you're designing things where people's lives could be at stake if you fail. And so, not everyone wants that responsibility, or not everyone has the math or science tenacity to succeed. And that's okay. I can't do an auto mechanic. I don't know anything about how, how to fix a car, but I have a different skill set. And so this class, we're going to be talking about mechanical engineering, but it could very easily apply to an auto mechanic as well. So we mentioned ABET. So ABET is the organization that accredits universities for becoming or for being able to offer an engineering degree. There's also the National Society of Professional Engineers, and this is the organization that certifies you as a professional engineer. So professional engineers are not, it's not required for every discipline, but there are some disciplines where it's really, it is required. So it's like civil engineering is one of them, mechanical engineering is another. And the steps to become a professional engineer is that you have to earn a degree from an ABET accredited university. You have to pass the fundamentals of engineering exam. So that's a 8-hour-long exam that some universities will require you to take before you graduate. You don't have to pass it before you graduate, but you have to take it before you graduate. And that's because it's really testing your knowledge of like general engineering practices. And it's 8 hours long. It's crazy. Then after you pass your fundamentals of engineering exam, you have to go work for about 4 years, and you have to do work under a professional engineer. After that, then you take your principles and practice of engineering exam. That's called your PE exam. And once you pass that, you can apply for licensure. So like I said, some disciplines require it. Some disciplines you might get a raise or a bonus if you're a professional engineer. Some disciplines, it's really not super necessary. It just depends on what kind of work you want to do. But if you want to be able to sign off on plans saying that they're safe and they're correct, you typically have to be a professional engineer. So there's another short little video that's really good. I've summarized the key points here of how to be a successful engineer. Be a good listener, be knowledgeable, get hands-on experience, and get the degree. So again, take a second to watch this video. You make some really great points. So engineering, we can see engineering at work all the time, solutions that work. So this is Three Gorges Dam. This was commonly featured on feats of engineering because it's, as you can see, it's quite large and robust. Internet, that's an engineering solution that works. Electricity, this is cool. This is an island that was built in Dubai, and it's completely man-made, and there are houses on it. Very, very cool. So engineering solutions are out there and they work. Sometimes engineering solutions don't work. So in this case, bridges don't line up. This is about 3 minutes long. It gets a little repetitive, but the link's there if you want to see some more engineering fails, because there are definitely a lot of failures. In this case, this company lost a lot of money, not a great idea, but it wasn't necessarily harmful. They're dangerous, but we know from experience here in Louisiana that engineering fails can sometimes be really bad. So this is the New Orleans levee after Katrina. That was an engineering fail. The levee gave way and allowed flooding to happen. And then there was the Fukushima nuclear disaster in 2011. Again, an engineering failure that cost a lot of lives and was a problem. So engineers aren't always successful, but your goal is to apply the concepts that you've learned and make the best decisions that you can. So that's just a little bit of a look into each of the different engineering disciplines that you're going to get to explore in this class. So stay tuned for some more great information.